Welcome, learners. We continue looking at testing for ions. Yesterday we looked at how you can test for cations. Remember, cations are positively charged ions, and they are mostly metallic ions. So all these copper ions, iron ions, aluminium ions, magnesium ions, calcium ions, zinc ions are the mandatory ions whose tests you must know at the Msce level. So recall that we discussed the test for these ions using aqueous sodium hydroxide solution. All right. Okay, so it's a must that you should know this table fully well. Okay, because Maneb or your teacher will not give you this table to use for inferring the identity of ions in an exam. So you have to know this. All right, you have to know this. The test, the procedure, the test result for when 3 drops are added, and the test result when excess of sodium hydroxide is added. Okay. Now, we can also test for cations or positive ions by using aqueous ammonia. Aqueous ammonia. Ammonia is NH3. So this dissolved in water. This dissolved in water will form aqueous solution of ammonia. So in order to identify a cation using this, all you have to do is add a few drops. So you add a few drops of aqueous ammonia to the solution which contains the cation of interest. All right, so you add a few drops of aqueous ammonia to the solution containing the cation, and then you note and record the color of the precipitate. It's as simple as that. All right, so what we're saying is, suppose we have a solution in a test tube which is suspected to contain the cation of interest, and then you add a few drops using a dropper. You add a few drops of ammonia to the sample. Okay, then you observe the color change. So most of the times, the color change is accompanied by, or is as a result of the formation of a precipitate. Remember that precipitate is just a solid product of a chemical reaction. So when a solid product is formed, that's called precipitation, and the product so formed is called precipitate. Very important to note. Precipitate is just the product of a reaction between two solutions, and it's in most cases a solid. So the table summarizes the expected results, the expected color changes, right? So if a solution contains calcium ions, let's say you have calcium chloride or calcium sulfate or any other solution of calcium compound, right? Upon adding 3 drops of ammonia solution, a white precipitate is formed. Okay, and the white precipitate remains in the solution even if you keep adding more ammonia solution. Right, so the identity of calcium ion upon adding ammonia solution is the fact that it forms a white precipitate. So if the product formed is a white precipitate, just know that the cation which is contained in the solution is calcium. All right. and it stays in the solution. It doesn't dissolve, it doesn't disappear, even if you keep adding more ammonia solution to it. That's very, very important. All right. Okay, if the solution contains aluminium ions, again a white precipitate is formed. A white precipitate is formed, and upon adding extra ammonia solution, the precipitate remains in the solution. Okay, upon adding, if the solution contains zinc ions, then a white precipitate is also seen, but upon adding more ammonia, the precipitate is going to dissolve, it's going to disappear. Okay, so the precipitate dissolves or disappears when the excess ammonia solution is added. A solution that contains copper ions, for example copper sulfate, will form a blue precipitate upon adding 3 drops of ammonia solution. Okay, and the precipitate dissolves or disappears when the extra ammonia solution is added. Okay, if a solution contains iron 2 ions, a green precipitate is formed. A green precipitate is formed, and this precipitate does not disappear even if more ammonia solution is added. A solution that contains iron 3 will be associated with a red-brown precipitate. A red-brown precipitate is formed, and it remains in solution even when additional ammonia solution is added. If a solution contains lead metal ion, a white precipitate is formed, and the precipitate remains in the solution and dissolved. So take note that there are 2 ways to detect cations. 1, using sodium hydroxide solution, aqueous solution. 2, using ammonia solution. So for each, I would urge you, for each of the reagents used, make sure you know the results, because once again, because your examiners will not give you this table for you to use as a way of inferring the product that, the ion that is present in a given solution. Right, so once again, my name is Mr. Pochilola. We'll continue to offer you quality education online. For the time being, all you have to do, if you are the first visitor, if you are visiting this channel for the first time, consider subscribing to the channel. It is going to be of help to you to subscribe to the channel so that you become notified every time a lesson is uploaded. When we meet again in the next lesson, we are going to look at testing for anions. Remember, anions are negative ions. These are negative ions. Alright, so we are going to look at the procedure involved and the expected results for each ion, negative ion. Once again, my name is Mr. Pochilola, wishing you a beautiful Sunday afternoon. Bye-bye for now.